an astounding exposure made by the James Webb Telescope. City lights in space found 7 trillion miles from Earth. This huge finding has sparked interest in the possibility of extraterrestrial life. The telescope zeroed in on Proxima Centauri B, the nearest exoplanet to Earth, revealing astonishing bright lights emanating from it. What could be the defense for these city lights on Proxima Centauri B? Might this, at some point, show the presence of life beyond our solar system? Join us as we delve into how the James Webb Telescope perceived these magnificent objects in space. For a seriously lengthy time span, analysts and the general population have hypothesized about existence beyond our close planetary neighborhood. Evidence suggesting life has been eagerly awaited. Actually, the scientific community was shocked when strong evidence of living things was seen by the James Webb Space Telescope while examining space and specifying vital data back to Earth. The James Webb Space Telescope noted impossible-to-miss city lights shimmering from the exoplanet Proxima Centauri B. These lights were precisely as its name suggested, lights resembling those illuminating a distant city. The possibility of an alien city existing on the star has left scientists confounded and bewildered, as it seems like the existence they've all been waiting for. Assuming that this turns out to be true, as everyone believes it will, it truly means that there are intelligent living beings building civilizations new to what people know in space, and we're just discovering it. Exploring the city lights that are found 7 trillion miles from Earth, NASA designers can't help but wonder how long these lights have been visible in space. David Kipping, a cosmologist from Columbia University, describes the Proxima Centauri B exoplanet, where the city lights were found, as captivating. He said so much because the star system closest to us has changed intensity patterns that aren't similar to other planets. The normal rocky planets are known to absorb sunlight and emit infrared radiation, but not so for this exoplanet, as its infrared nature is generally different from that of its host star, named Proxima Centauri. This requires a good observational eye by the James Webb Space Telescope, JWST, and the telescope proved to be valuable as the right instrument for the gig. The JWST can actually perceive infrared frequencies. The particular power characteristic of Proxima B will be a critical part in uncovering the universal secrets of its atmosphere, and that will be done thanks to the latest technology of infrared imaging capabilities. Advanced by the JWST, scientists hope to use the telescope to uncover the organic elements of this planet at air levels. They furthermore plan to use the Webb telescope to investigate the possibilities of life on this exoplanet. The James Webb Telescope has an infrared awareness that is ready to research what happens on Proxima Centauri B's evening. Getting the smallest light emissions in the vast darkness is generally a challenge for space telescopes, but not for the JWST, as it can detect even the smallest light emissions from space. It's the perfect tool to check if the reports about city lights on Proxima B's night side are valid or not. Not every artificial light in the universe can be detected by the telescope, as long as it falls within a frequency band that is many times smaller than the starlight. Proxima B has an interesting relationship between its celestial elements and surface conditions. The day side of the exoplanet contains various solar chargers that harness the blazing solar energy emitted by the star, while its spectra edge reflects incoming light beams. Meanwhile, when Proxima B completes its orbit around its host star, Proxima Centauri, it experiences day and night cycles like what we have on Earth. With the daytime getting high on solar intensity and the nighttime experiencing coolness, the planet is known to have temperature differences regulated by its structure. For instance, assuming there's no atmosphere on Proxima B, the difference between its day and nighttime cycles will be wide and far between. Assuming there's no moderating effect of atmospheric gases and oceans, the temperature of the day side will be scorching hot like a dark body, and the nighttime will plunge into cold darkness. The degree of temperature variation is a ripe subject for astronomers to unravel a deeper understanding of Proxima's atmosphere structure. Having an unparalleled infrared imaging capability, the JWST can indeed investigate the planet's thermal emissions to provide wise information about its organic properties. Interestingly, the orbit of the James Webb Telescope around the Earth lines up with Proxima B's orbital period, giving a complete view of its 24-hour cycles within 11.2 Earth days. Since it indeed has an atmosphere, the next step will be to evaluate its environmental science to determine whether it can support life. A couple of nice pointers in deciding if there's life are the presence of gases like oxygen, water vapor, and methane. If these elements should be visible on the planet, it suggests that it maintains viable conditions. The task of precisely determining this anticipates researchers to be cautious enough as they gather and analyze light beams that pass through the planet's environment. This is a very difficult task to attempt. Although the JWST has incredible capabilities for characterizing planetary atmospheres, it has a primary objective. The telescope has been programmed to only investigate the variations in water vapor, carbon dioxide, and methane concentration when it comes to detecting enhanced oxygen, which is a critical sign of something going on deep below. The JWST is limited in this area. Nonetheless, the telescope still has critical motivations to look for other elements on the planet like ozone, which offers a precise measure of significance in the atmosphere. The fact that the James Webb Space Telescope doesn't have comprehensive capabilities, and it can't peer at a few of the nearest possible worlds to Earth, leading an exhaustive air assessment, space specialists are now leaning toward ground-based observatories like the Extremely Large Telescope, ELT. The ELT is a telescope that has been designed to start operating in 2028, and it's strategically positioned to look deeper into the atmospheric composition of remote exoplanets. It'll provide data on these planets that will offer comprehensive and clear insights into their degree of habitability. NASA scientists and everyone are eagerly awaiting the deployment of future space telescopes like these. Up until that point, however, the James Webb Space Telescope remains a crucial tool in our journey to uncover the mysteries of distant exoplanets. Even with its ongoing limitations, the Webb Telescope has the potential to offer significant insights that will revolutionize how we interpret exoplanetary research now and in the future. Researchers have a goal for future space telescopes, and that is to reduce the amount of bright light coming from a planet's host star so astronomers can better see the lights reflected from a planet itself. They intend to do this by using internal shades or large external sun shades that are shaped like an umbrella, using your hand to block out beams of sunlight to enable you to see an object clearer, reducing the overpowering brightness coming from the host star. Future telescopes will be better positioned to focus on faint impressions of light coming from a distant exoplanet, allowing for clear analysis of its atmosphere and probability of supporting life. Doing this comes with its own challenges, however. Scientists should recognize gases produced from life and those from geological cycles like volcanic activity. Astronomers aren't giving up on understanding the characteristics of exoplanets, so they're more equipped to detect signs of something going on a deeper level and distinguish them from misleading upsides. The Webb Telescope epitomizes a similar time. A notable story has spread recently that a few aliens are truly something different in the stars, just hoping that people will find them to offer an answer to this question. Two American space specialists, Jill Tarter and Thomas Pearson, began an endeavor called the Search for Extraterrestrial Intelligence in 1984, known as the SETI Association. It is a charitable endeavor that aims to sift through cosmic signals to simply get radio transmissions from space. The legitimization behind focusing on radio transmissions is a consequence of their ability to travel huge distances without getting dispersed or held like different kinds of radiation. Thanks to this brand name, radio transmissions are bound to be recognized by the 42 radio telescopes that make up the Allen Telescope Array located in the foothills of California. However, the SETI Association has thoroughly observed indications of these radio transmissions made by extraterrestrial life. There haven't been any such signals for more than 30 years. Jill Tarter is stimulated that they'll have a positive outcome as they need to utilize the instruments of the 21st century to speed up the pursuit. In the verbalizations of Jill, "I wish that you would enable Earthlings everywhere to become active participants in the ultimate mission for extraterrestrial affiliation." All of that went on until late reports from NASA suggested that the James Webb Space Telescope spotted city lights from a planet close to Earth. The JWST is the game-changer played by individuals in figuring out the universe. It's already the most advanced instrument in all of mankind to reveal all of the mysteries of the universe. The telescope is currently floating around 1 million miles from Earth, sending detailed insights concerning the earliest times of the universe. It's expected to get the beforehand subtle insights viewing space as it conveys greater clarity on the evolution of space, galaxies, planets, and stars. Cosmologists haven't neglected to gain by the JWST's cutting-edge advancements. For example, its brilliant camera element and filters to detect and analyze the delicate tones that surround superb objects. Experts are amenable to using the telescope to gather data about the true properties and chemical compositions of heavenly bodies found far away in the universe. This was accomplished by isolating specific frequencies of light far beyond just observing. The Webb telescope constantly examines the climate of exoplanets for faint hints of life, paying little heed to how small. It has an unparalleled ability to explore the presence of life and has revealed some of the most fascinating discoveries ever. One such is the discovery of something else in mass than what was previously believed to have existed in the universe. This mass has been found in several giant systems, casting doubt about the earliest configuration and breadth of the universe. Humanity has since decided to explore the farthest spreads of the vast plane using the JWST as an essential instrument for achieving this. Through the telescope, new information on far-off galaxies will be recorded, and more astrophysical data will be available, ready to address the mysteries of these planets. Years back, the vast space outside our planetary group wasn't explored. Since that time, however, astronomers have identified north of 4,000 exoplanets that circle distant stars, showing exactly how far human ingenuity can go. Still, these discoveries are seen by NASA as touching the tip of the cosmic iceberg. Scientists are of the opinion that, in reality, there are trillions of exoplanets littered all around the universe that haven't been discovered. Not giving up, over time, scientists are still exploring space with at least some hope of fishing out alien environments where people haven't ventured. They've had promising signs during this mission. Occasionally, when Galileo hopped on a bus going to Jupiter, its spectroscopic instrument accidentally revealed an intriguing spectral signature that lent credence to extraterrestrial vegetation. This was the beginning time scientists found a profile that indicated the presence of life in the universe. This biomarker was the vegetation red edge known as VRE. The VRE seeks extraterrestrial life, particularly by offering close attention to the way it reflects light. With the help of the VRE, the James Webb Space Telescope is expected to reveal the secrets of extraterrestrial environments through the careful examination of orbital constraints of potentially habitable planets resident in the habitable zones of their alien parent stars. Once these are identified, the VRE can provide valuable evidence in the mission for intelligent living things outside Earth, opening a new adventure in uncovering the mysteries of the universe. When sunlight goes through the atmospheric layers, the scattered light, which carries with it unique frequencies, gets absorbed by the particles and molecules found in these layers. As the absorption continues, a specific spectral pattern that is associated with specific fingerprints is formed that can be deciphered through spectroscopic analysis. It's a common theory that when light from stars reaches a planet, the Webb telescope will be able to recognize it as it enters the planet's atmosphere. This data suggests that the JWST could be the missing link to uncovering the organic composition of these Earth-sized planets and planets that contain atmospheres rich in carbon dioxide, nitrogen, and oxygen. However, these types of planets could potentially support life. The lack of unique compounds could highlight alternative forms of life, and industrial advancements like chlorofluorocarbons, CFCs, known as man-made chemicals used for refrigeration and other industrial purposes, could help scientists in proving the existence of extraterrestrial development. Truly, if the JWST notices such artificial particles in the atmosphere of exoplanets, it'll be clear evidence of extraterrestrial activity beyond our planetary group. This opens up a new window for vast researchers to examine the environmental compositions of other worlds and the slim probability of alien civilizations. Beyond and past the sleek way life away from Earth is portrayed, by a large number of possibilities that transcend the limitations of organic.